College Algebra, Chapter 2, Section 4, Circles. We're going to do a little bit here just with circles. There are other conic sections we'll get to later on in the text. But right now, we want to learn about circles. Objective 1. The standard form of a circle. A circle, if you want to draw a picture because it's helpful. There is a center that we usually call HK. It has a radius R, and then all these points that distance away are points on the circle. This is R. So, if we need to graph that, we need to know HK and R, and the standard form is, in parentheses, x minus h squared, that quantity, subtraction, very important here, plus y minus k, that quantity squared, subtraction here, also very important, equals the radius squared. That is the standard form. Now, if we've got a special circle, h and k, at the origin, this reduces to x squared plus y squared equals r squared. Sort of nice, short, nice form. So how would, objective 2, how would you graph a circle? Well, it all depends, I guess. First of all, you got to put it in standard form. Then you plot the center and several points, and then you can connect those dots. Let's suppose, let's see here. See if I can find my example. Where'd it go? Okay. Suppose you have x squared plus y squared plus 4x plus 2y minus 20 equals 0. So the first thing you need to do is put it in this form. These are binomial squares. So we're going to use that completing the square process. We're going to take the x squared and the 4x, and we're going to add some to that. We're going to take the y squared and the 2y and add something to that so we can complete those squares. We're going to put the 20, add 20 to both sides, so put this on the other side. And of course, we're going to need to add those two things to the right that we added to the left. So, what do you add? Well, let's see here. Remember that process. You take the middle term coefficient. This first one is a 4. And you take half of that and square it. That means that on the right side, I'm going to add 4. 2 squared or 4. Here, once again, the middle term, the linear term, the 2, half of that, and square it. So I'm going to add 1 to the right side. Now I'm going to have to squeeze this in a little bit, but remember, this becomes then square root of x squared, which is x, the sine of the 4x, which is plus, the square root of 2 squared, that's why I wrote it as 2 squared, it's just a 2, the quantity squared, plus square root of y squared is y, the sine of the 2x is plus, and the square root of 1 squared is 1, quantity squared equals, well, let's see, this is 25. And it's probably better to write this as 5 squared, because it's the radius squared. And so don't get that confused with 25, it's just the 5. So, if we go over to, let me see if I can do this. Oh my goodness. So, we're in the wrong place. Let me go to a new screen. It's x plus 2 and y plus 1 and 5. New screen. So, x plus 2 squared, y plus 1 squared equals 5 squared. Now, let's do this a little nicer. Remember, this is supposed to be x minus and y minus. So these are really negatives. This is really a negative 2. It's really x minus a negative 2. So I'm going to go to the left. And this is really y minus a negative 1. I'm going to go down 1 unit. That is where the center is. That is my HK. The negative 2 and the negative 1. R is equal to 5. So we go 5 to the right, 1, 2, 3, 4, 5. 5 to the left, 1, 2, 3, 4, 5. 5 up, 1, 2, 3, 4, 5. And 5 down, 1, 2, 3, 4, 5. And then we connect these dots, if I can do this. No. Not bad. That is how you would graph it. Put it in standard form. Plot your center, measure off your radius, right, left, up, down, connect the dots. So, what is objective 3? The general form of a circle. Now, you might say, hold it, didn't we just do that? No. The standard form of a circle is x minus h squared plus y minus k squared equals r squared. The general form is ax squared plus, I guess they're going to do, I'm going to do the bxy. I'm going to put this in here for now. This won't make a lot of sense right now, but cy squared dx ey plus f equals 0. Now, this is really the general quadratic in x and y. What we're going to do for this general form of a circle is we're going to assume that b is equal to 0. So that term will not be there. We also know that a and c will be exactly the same. So if we divide everybody by a or c, because they're the same, we won't need those variables. We'll just need the x squared and the y squared. And we're going to say d divided by a is still going to be the d. The e divided by a is, we're going to call that e because it's just some constant. Plus f equals 0. Our book probably says this can be a, b, and c, but I'm going to call it d, e, and f. A and c are the same. Really, it's what I used on that previous screen to figure out how to put this in standard form. So it's x squared, then y squared, then x, then y, then a constant. That's the general form of a circle. If you got 2x squared and 2y squared, you might as well divide everybody by 2. Get it down to the x squared and y squared. Let's take a look on page 193. At some examples. If we look at number 10, which gives us a graph. And they say there's a circle someplace right here. This is the x-axis. This is the y-axis. They say there's a center right here, but they don't give us the center. They say this crosses at 0, 1. And they give us another point on the other side here of this diameter. The point is 2, 3. Find the center and the radius of each circle, and then write the standard form of the equation. So how do you find this center? Well, from the point 0, 1 to 2, 3, the center, because this is on a diameter, we have to assume that, it's going to be the midpoint. So what is the midpoint? 2 plus 0 over 2, and 3 plus 1 over 2, which is the center, HK, 1, 2. Does that make sense? Yeah, it really does. 1, 2. So HK, the center, is 1, 2. How do you find the radius? Well, you want the distance from the center to one of these points. Let's use this point 0, 1. So we want the distance from 1, 2 to 0, 1. Distance. So y sub 2, I guess do the x's. X sub 2, 2 minus 0 squared, plus y sub 2, 3 minus 1 squared. So the distance is the square root of 2 squared plus 2 squared. So it's really the square root of 8, because this is 4 plus 4, which we can write as 2 times the square root of 2. So the radius is 2 times the square root of 2. Now, they want as a final answer the standard form, which uses the center and the radius. So they want x minus h squared plus y minus k squared equals r squared. Not so bad. Let's do one more of the standard form converting to, general form converting to standard form to figure out how to graph it. Let's do number 32. Two x squared plus 2y squared plus 8x plus 7 equals 0. Now, how do you know this is a circle? Well, you get this form, and the a and the c are exactly the same, and b, you don't see it in there, the xy term. So you know it's a circle. And you also know that's the section we're in here. So I'm going to divide everybody by 2. X squared plus y squared plus 4x plus 7 halves equals 0. And now I'm going to complete the square on the x's. X squared plus 4x plus something plus, and what you notice here, since there's no y term, you know that it's just y minus 0 squared to get y squared. Now we've got the negative 7 halves, and we have to add just one thing, because we just had this y minus 0 here. Half the middle term, 2 squared, 2 squared, or 4. So this becomes square root x sine plus square root 2 quantity squared. This is the square root y minus 0 squared. Now 7 halves is really 3.5, right? And to get to 4, you need a positive 1/2. But we need the square root of that to get our r. And all they want for the directions is find the standard form. But I might have you also graph this. Let's see here. We need a center of -2, 0. So a -2, 0 is the center. So we're bringing in our calculator. Remember, the square root of 1/2 is the radius, not the squared part. It's not 1/2 for the radius, it's the square root of 1/2. So I'm going to find approximately what is the square root of 1/2. Let's see, let's clear off this stuff from before. And I want the square root, I'm going to put in 0.5 because it's just a little bit easier. Doesn't really make any difference. So it's 0.707. So I don't know, like it's not quite 1. My goodness, I made my stuff too big. Let me put this down. So 0.7 is really tiny. It's like here, 0.7, 0.7, 0.7, 0.7. This is a tiny little circle right there. Radius of 0.7. -2, 0. So, see what you can do with these circles and make sure you can complete the square, because you'll have to do that for many of these problems.